Yes, what's up everyone, Homemade Madness, welcome back, and you've read the title. It's happening, I'm building a massive CNC machine. You're gonna need huge ball screws, stepper motors, linear rails, big amounts of steel. It's gonna be amazing. Let's dive in. Yep, so ever since I dove into the world of CNC last year to build myself a CNC plasma table, I already knew that one day I wanted to build myself a CNC milling machine or router or whatever. So if you don't remember, this is my homemade CNC plasma cutter, really an amazing tool. I've used it in every single project ever since I built it. And I know a lot of you have built it along with me because I sell plans on my website and they come with DXF cutting files and wiring instructions, everything you need to make this machine. Anyways, building this plasma has really opened up the world of CNC machining for me and made me realize, well, building a CNC machine yourself is not as difficult as it might seem. So right after I finished the build, I built myself a CNC tube notcher. And then I bought this old CNC lathe and made it modern again with new motors, new wiring and new control software. So it's kind of crazy how I went in less than a year from 0 CNC machines to having built 3 and now building my 4th. So it's kind of addicting, and making a CNC machine and then having it do your work for you is super pleasing to watch. Anyways, I've been thinking quite a lot about how I want to build this next CNC milling router machine. So generally there are 2 types of rotary cutting CNC machines. First you have a CNC router which moves with a gantry over a table and usually cuts sheet goods like wood, aluminum or acrylic. And then you have the CNC milling machines which look kind of like a drill press, with the cutting head being stationary and the table moving under the cutting head. And they usually have a way smaller working envelope and are meant to cut steel or metal. So I've been doubting a bit about which one of these 2 machines I should build, but I couldn't really find a machine which has a big working area and is still stiff and powerful enough to cut steel. That's basically what I want to make here, a massively heavy CNC router made completely out of steel, with powerful driver motors, a massive spindle on there, which can cut wood, aluminum, sheet goods, but also cut steel, drill steel, tap steel, do everything in one package. And combining the 2 machines into one means you don't have to give up valuable workshop space for 2 separate machines. And also it will save me money because I only have to buy 1 spindle, 1 set of motors, 1 controllers, etc. And also I wanted to have a flood coolant system to wash out chips and keep everything cool when you're machining metal. And also I wanted to have an automatic tool changer so it can automatically change between cutting tools. And it needs a dust collection system to suck up the sawdust when I'm cutting wood. So with this in mind, I went to my office and started engineering. And this is what I came up with. This is the main frame of the CNC, made of massive steel tubing filled with concrete to make it stronger, heavier and to dampen vibrations. Then on the underside of the 2 tubes we have the machine bed. This is where we place the material we want to cut. And on the top of the tubes we have the gantry, this thing, riding on linear rails driven by ball screws. On the gantry we find the Z-axis which can move up and down like this. And this massive spindle will do all the cutting. So the machine has a usable cutting area of 4 by 8 feet, so 1 sheet of plywood. And all motion will be driven by 4 2 kilowatt servo motors. And the spindle itself will be 9 kilowatts or 12 horsepower, which is crazy powerful, but that means we can do faster cutting. And because everything will be super rigid and heavy, it should have no problems cutting some steel. And all of it will be driven by the Meso G3 Touch CNC controller. And just browsing on the internet and YouTube and stuff, I couldn't really find anyone who has built a machine like this. Maybe that's for a good reason, but there's only one way to find out. So in the following episodes I'll talk more about all these components and the electronics, all that kind of stuff. But in this video I want to start building the frame. So looking at the frame, you can see the height of the gantry is gained by using the frame itself instead of the usual 2 plates on the side of the gantry, which are kind of flimsy, and this design will make it much stiffer, which is exactly what we need. Also with this design the ball screws are moved up higher, so further away from dust and metal chips. And also the frame itself makes for a nice housing to keep in all the chips and coolant. And this side of the frame is lowered so I can still have longer workpieces sticking out of the machine. And also I think it's worth mentioning I want to build this machine in this workshop myself, only using the tools I have here. My CNC plasma table, my welder, some hand tools and some clever techniques, and that's about it. So with all of this finally said and done, let's get some steel and start building. So to get started on the build, I first ordered these 2 massive pieces of box section, and just getting them into the workshop was quite a hassle, as you can see. Okay, so that's the first bit of massive box section in the workshop. I do have another one still on the trailer because I don't think I can fit two of them in my workshop. And next challenge is to get it on the bandsaw so I can cut it in pieces. And this profile weighs about 50 kilo a meter, and this is 6 meters, so about 300 kilos. And my workshop crane is rated for 200 kilos, so we'll see how it goes. And the crane definitely didn't like it, bending quite a bit. But as you can see, it did manage to do it. So this is my homemade workshop crane. It is super simple, I built it in about a day, but it is absolutely essential to the workshop. And frankly, I couldn't do without it anymore. Okay, the crane definitely didn't like that, but got it on there. And this is actually a 150 by 250 millimeter profile. And the saw says it should be able to cut 150 by 245. So kind of cutting it close, but let's see if it can do it. Okay, so don't ask how, but it did cut it. It was really close though. And it only worked because there's a small radius on this square tubing. And that made it possible for the saw to just slip by it, although I did have to help it a little bit. But it does cut it, and that's a big win, because I was already kind of expecting having to cut all of this with the angle grinder, which would be a lot of work. But luckily it does work, so I'm gonna do some more cutting, and I'll talk to you again once I'm finished. Right, first pieces are cut, and before I can weld them together, I first need to cut some holes in the tubes, so the concrete with which I'm going to fill the entire frame can flow through all the tubes around all the corners, and also I can put reinforcement rebar in there as well. So to cut these holes, I'm just going to use some offcut from this tubing to kind of use as a template, and then cut the holes inside this offcut with the plasma torch. And of course I got my drawing showing where I need to cut them. And if you're wondering what happened to my nose, well, I was trying to change the blade on the bandsaw, but as soon as I took off the tension of the blade, it popped off with the teeth into my face. Anyways, let's do some plasma cutting. So here you can see me cutting some holes into the legs, because I really want the concrete to flow in every single piece of this frame. Now concrete isn't the best for a frame like this. Something like epoxy granite would be even better. But with rebar in there it won't crack, and it will make it super stiff and heavy, which is a good thing. But it won't be just regular concrete, but I'll show you some more of it later in the video. Okay, so I got all my holes plasma cut in my main frame beam. And once again these holes are there so the concrete can flow into every part of the frame. So I also made some holes in the legs here to fit these cross brace pieces, which will go on something like this. And then to strengthen the concrete even more and prevent it from cracking, I got some 12mm rebar over here to go into the frame, and also through the holes into all the bed supports, as well as in the legs and the cross bracing. And also I'm going to weld some short pieces of rebar here and there in all the parts of the frame to anchor the concrete to the frame. And once that's done, I can finally start welding everything together, which is going to be a lot of welding. So here you can see me weld two shorter pieces of rebar in, kind of in a cross pattern. And this cross makes for a perfect place to mount two long pieces of rebar in the length direction of the frame, perfectly suspended in the middle of the concrete, like this. Okay, starting to look like something. 2 big main frame beams. This thing is gonna be absolutely massive. And these are the parts connecting the two. Later on they will go in here and of course in here. And also we need to make the bed, which will be made of a lot of square tubing going from here to here on the other side of these beams, like this. And to weld everything up, it's probably easiest to flip everything around and weld it like that, so I can easily access the underside. Only problem with that is flipping it back upright afterwards, because my crane is kind of already not able to lift these two. But that's a problem for later, so first thing I'm gonna do is flip these two upside down, then make sure they are positioned right, so absolutely flat, square and level. And then probably bolt them to the concrete, just to make sure they don't warp as I weld everything. Then connect them with the 2 main front and rear beams. Then weld all of the little pieces in between. Then flip it back upright somehow and fill it with concrete. So with everything in place, I did decide to bolt down the frame to the concrete. And this will definitely help prevent some warping, but it also won't stop it completely. With so much welding in this frame, there's always gonna be some stress and warping, no matter what. But I can do some things while welding to minimize the stress in the material, which I'll show you in a minute. But no matter what I do, I already know this frame is nowhere gonna be near straight and flat enough to mount the linear rails to which the gantry will roll. Which of course need to be pretty much perfectly flat in order to get precision with this machine. And flattening a frame like this is actually a big topic when you're talking about homemade CNC machines. But I have a plan for that, you'll see very soon, just keep watching. So here measuring against the laser line to make sure everything is still pretty much level. Then using a big chain hoist and measuring diagonals to make sure everything is still square. So with everything tacked up in place, it's time to finish the welding. And to minimize the stress in the frame while welding, I'm using a special technique called stitch welding, where you basically just weld like an inch at a time. Then move to another spot, weld an inch there, move to another spot and weld an inch there. And it's kind of annoying moving around all the time, but it does minimize the heat input and therefore minimizes the stress in the metal. And here I'm just putting a piece of wood into all these bed support tubes. And that way later on when I fill it with concrete, concrete won't go where the wood is. And that's useful for later on because I'll be drilling and tapping into these beams to actually mount my machine bed. And this way my drill and tap won't hit the concrete when it goes through the steel. And now using my homemade CNC plasma table to make some plates to close off these tubes. This is really an amazing tool. I built it about half a year ago. I couldn't do without it anymore. Super useful. Okay, so that's the frame all welded up, and next job is to flip it around, which is quite a big job because this thing is heavy. And all I have to do with is my little homemade jib crane right here, and I'm pretty sure it's not up to the task. So what I'm gonna do to make it a little bit stronger is use like a snatch block with a pulley system, and then put some support pillars at the end there, and hope that way it can lift it and flip it around. Okay, new plan. It's too heavy, the crane can't even lift it, even with the pulley in there. It's also getting a bit dangerous. So what I'm gonna do is move the pallet jack under there, see if I can lift it without it tipping over. Then move it outside and flip it over with the wheel loader. Alright, the frame is flipped. Actually went a little bit better than expected. Anyways, next job is to fill it with concrete. And my original plan was to just use concrete bags and then mix them and fill the frame. But actually I have a better idea. I currently have a big project going on for my own company, my job. And I'm building a stable for a farm next door. So what I'm gonna do is take the frame there, fill it with concrete, which we're gonna pour there tomorrow. Order a little bit extra concrete, fill the frame with that. Much easier, faster and cheaper. But the problem is I already got the concrete pour scheduled for tomorrow morning, 7 AM. It's currently past 7 PM the day before, so I better hurry up. Finish all the welding, fill up all the little holes, cut some holes to actually pour the concrete in, drive it to the job site, and then tomorrow morning I'm gonna pour it. See you then. And in case you're wondering why I haven't been uploading that much this summer, well, it's because I've been building this monstrosity all the way from engineering, pouring the concrete, welding all the steel and putting it up. So I moved the frame here, and after pouring all the other stuff, luckily there was still some concrete left. Now this is not just regular concrete. First of all, it's extra strong. Secondly, it's been made more liquid, but not by adding water, which makes it weaker and more prone to cracking, but by adding a plasticizer in there, so it will flow into the frame. And once again, something like epoxy granite or UHPC or even sand is also an option. But this will be stronger, much cheaper, and also of course really heavy, which is important because it moves the entire resonance frequency of the entire frame down, which in turn means it won't vibrate as much. So I'm using the concrete vibrator to make sure it goes into every single nook and cranny of this frame. And in total almost 1 cubic meter of concrete went in there, which now means this frame weighs well over 2 metric tons. So about a week later it was, well, almost pretty much cured and ready to be picked up again and moved to the workshop. Okay, frame filled with concrete, managed to get it back into the shop. Don't ask me how. Anyways, super pleased with it. Feels nice and solid. Everything is properly filled with concrete. So I think this video is already growing pretty long, but I still want to do one more thing, which is leveling the bed. As you can imagine, this frame is pretty flat, but it's far from perfect. The tubes will have twist in them from the welding. It may have been twisted a little bit this way or dip. And if we leave it like this and mount the rails on here, the router itself will also dip, making everything curved or crooked. It just needs to be perfectly flat. So the question is, how do I get this frame perfectly flat now? The best thing would be to have an even bigger milling machine, mill a bit of both surfaces and make it flat like that. But that means having a machine even bigger than this one, well, that's just not going to happen. So another thing I can do is just shim the linear rails, which will go on here, with some shims and flatten it that way. But that's really a tedious job and also really hard to get perfect, because they don't just need to be flat, they also need to be coplanar, so not like this, or like this. But anyways, the way I'm going to do it is by using a technique I don't really see a lot of people do on the internet, which is using epoxy. So the plan, make a mold on both sides where the linear rails are going to be. Then connect the two halves with some bridges in between. Then get the thinnest, most flowy epoxy possible, and it also needs to have a really long curing time. Then before the pour I'll heat it up to make it even more flowy. Then pour it in the molds. It will self-level both sides and also make them coplanar and super flat. And then in theory it should become just as flat as the curvature of the earth, which in my mind is pretty damn flat. And then we should have a super flat, nice coplanar surface to which we can mount our linear rails and get started on making the gantry. Let's give it a shot. So first job, weld these pieces back in place, which I used to make holes to fill the frame with concrete. After that, clean up this surface to make it super clean and add some roughness for the epoxy to stick to, and then start making the mold. Right, the mold is done. I sealed it as good as I could with some caulk, so I hope it doesn't leak, but well, there's only one way to find out. And currently I'm preheating the steel frame with some hot air blowers to kind of heat it up a little bit, so the epoxy won't go cold instantly it touches the cold steel. I'm hoping it will help to keep it liquid just a little bit longer, so it will self-level even better. And also I've been preheating the epoxy in a tub of hot water, and it should be around 40 degrees Celsius right now, nice and liquid. And with all that done, it's time to mix the epoxy, pour it in, see if it doesn't leak, and hope it gets super flat. So far so good. Okay, I can confirm it's super flat. I can't even get a single piece of paper under there anywhere. That's a good sign. This side as well, not bad. Now let's see if it's level. Okay, so put 2 spacers on here to make sure I get the middle of the epoxy, not the edges, because the edges tend to curve up a little bit near the mold. Anyways, check this out. So, I know what you're thinking, it's not perfect. 1 stripe off. But don't forget, this is a 0.02 millimeter per meter level, which means that side is only 0.02 millimeters higher than that side, which is thinner than a human hair. So I'm gonna say this is pretty flat. And just to show you how accurate this level really is, it can measure the bend of this massive steel profile over this length, because if I move it to the side, you can see the bubble goes to this side. And if I move it to the other side, the bubble goes to that side, and in the middle it's pretty much perfect. So that shows just how accurate it is, because it can measure the deflection of just the weight of this profile, which is really thick and heavy. So this is a crazy accurate level, and it measures only a tiny little bit off. So I'm really happy with this. This is better than I was expecting. Okay, so that's it then for part 1 of the monster CNC build. We built this super tough, concrete filled, super heavy frame. Nice, stiff, heavy, vibration dampening foundation for me to mount the gantry on in the next part. And then of course also on the gantry there will be the Z-axis with the milling head on there, which can move up and down. But in the next part of this build, I'll first mount the 2 heavy duty linear rails on this super level epoxy surface, and then we'll start on the gantry. So the epoxy pouring technique itself, I wasn't too sure about it. I talked about it with some other people, they weren't too sure about it. Is it gonna self-level? Is it gonna be strong enough? Isn't it gonna shrink and do all kind of crazy stuff? Isn't it gonna leak and basically create a puddle that way? Nope, didn't. Super flat as my straight edge. Can't get a piece of paper under there anywhere. It's level, and this water level is actually way too precise. 0.02 millimeters per meter. And because I work in construction, I use a water level all the time. Of course, a normal one, not this one. And I'm used to seeing the bubble being perfectly in the center. And with this one, I didn't see that. It was off by a few stripes. So when I first saw that, I was pretty worried about it, because I figured the epoxy pouring technique hadn't actually worked all well, and it wasn't flat nor level. But then I realized just how accurate it is, and a piece of paper makes all the difference. And the epoxy turned out actually to be pretty much perfect, actually way more perfect than I was hoping for, so absolutely a win. And I'm gonna use it again to make the gantry flat and some other stuff. And I've got some other very creative ideas on how to build the rest of the CNC without using another big machine, just hand tools and some clever techniques. So I hope you enjoyed this video, and I hope to see you again in the next video. I can't wait to have this beast finished, because I have a lot of jobs for it and I really need it to be done. So I better get started on building this gantry and mounting the rails, and I'll see you in the next part.